right, everyone, let's get started. Welcome to today's webinar. My name is Paula Bernstein, and I'm a consultant here at PRAY, and I'm part of the database team, and I worked on the implementation of the Agribalyse database into our SimaPro software. So just a few housekeeping items. We are recording the webinar, and everyone is on listen-only mode. We'll have time for questions at the end, so if you have a question, please submit it right through the chat box. The agenda for today, we'll start with this brief introduction, then I'm going to pass the presentation over to Vincent to talk a little bit more about the Agribalyse database. One other thing I want to make clear before we start is that the Agribalyse database is since it's a specialty for the French conditions, we've not included it in our typical regular update, but it is available for download on SimaPro.com, so you can just download it for free and import it into your own library. So I'm going to introduce our speaker, and then I'll pass it along to him. Vincent Colomb is a project manager at ADEME. He's in charge of the LCA projects related to food products at the French Environment and Energy Management Agency. He got specialized in environmental assessment of agricultural and forestry products, working for consultancies and research institutes in the past. At ADEME, he's been coordinating Agribalyse program for the last 4 years and promoting LCA research and development at the national and international level. So without further ado, I'm going to make him the presenter, and you can take it away.
Thank you, Paula, for this nice introduction. I'm very glad to be here with you today to present our work. Indeed, since we're now broadcasting Agribalyse 1.3 directly from SimaPro platform, we thought it would be interesting for users to explain a bit more about our work and to be able to answer your questions. So that's the topic of today. We will let you know everything about our database and the French work on agricultural LCA. My name is Vincent Colomb, and I'm working at the French Environmental Agency. So here we go. I'll start with a short introduction, then we'll go into the database content and our methodological choices. And at the end, I will open for a broader topic of what is the Agribalyse program, because it's not only a database. So a quick word about the French Environmental Agency. We are a public agency depending on the Ministry of Environment, and our role is to support ecological transition. In order to do this, we have three main means. First one is by supporting knowledge about sustainability. We work with research teams, and we are not a research institute, but we are funding research programs. We are a center of expertise, so we advise the policymakers and the companies regarding the sustainability questions. And finally, we have an investment capacity. We can support green factories, renewable energy, and to develop sustainable projects on the different regions of France. Agribalyse program was started in 2009, and it had really two main means. The first one being support the eco-design, eco-conceptions for agricultural practices. So the idea was really to give benchmark, to know which practices would be more favorable to environment, and to build this knowledge. The other aim was communication with all the eco-labeling schemes that have been developed and tested in France for the last few years. And so all those data are really meant to support these labeling approaches. a brief history to understand where we are now. I think it's good you have a quick look on the past and how it developed until now. So there's been three periods for Agribalyse. Like the first one was really like the beginning of the brainstorming. It was in 2007 with a deep review on agricultural LCAs that were available for France, with the view that it was really a complete lack of data, heterogeneity of data, lack of comparability, and so that the companies and the different stakeholders basically starting from zero. And France was a bit behind on all those information and knowledge. At the same time,
Vincent, I think you cut out. Let's see if we can try to get him back. Hold on, everyone. Sorry. Vincent, can you hear me? It looks like he might have lost some connection. Vincent, can you hear me?
yeah, I can hear you. Can you hear me?
Yeah, you cut out for a second.
Okay,
Maybe
well, sorry,
maybe like
network.
Yeah.
This morning worked perfectly for 1 hour, so I hope I switch off my camera to save some waves.
Okay. Yeah. Up a little.
I guess it stopped when I was mentioning the granules, right? Did you hear that part?
Yes.
Okay, good. So yeah, that was in 2009. That was acknowledged that the LCA should be the methodology applied for product assessment and product environmental performance communication. So following this period, we started this Agribalyse program. During 4 years, we work on developing the database and the methodology. And we published it in 2014. All the data on the main food, on the main agricultural production. And after 2014, we discussed and decided it was worth to go on with the program, to maintain the data and to further develop as several limitations had been identified. I will give you more information on this part at the end of the presentation. However, it's important to realize that now I'm losing my... Yeah. That we are not working alone. There's all this background that is also affecting our work. And so that's a few examples that has been currently ongoing at the same time as Agribalyse. So there's been this GHG database also managed by ADEME, so that has been compulsory for companies to use from the early 2010. Then there's been all the eco-labeling work at the French level and also the European level. And so all this work has had some strong connection with Agribalyse. Agribalyse database is also important thing to have in mind is that it's really a common work, common value, shared data and methodology for the French stakeholders. So that's in a concrete way, that means that in the coordination, in the steering committee, we have the public authorities that are represented, so ADEME as coordinator, but also the Ministry of Environment, which is strongly involved. We have the private sector with the technical institutes and the agricultural cooperatives. We have the research with the INRA, the French Agronomic Center, and CIRAD, with more focus on overseas territories and tropical production. And finally, we have also associated experts, so that are not like full member of the committee, but are here to advise us and connect with all the international initiatives. And one last person that is really important to mention is concerning the calculation implementation. So it's Peter Koch, working as consultant, who was a previous agroscope manager in Agribalyse 1 and was been in charge of latest update of Agribalyse and calculation tools. So let's now look into more details into the database content. So Agribalyse is really focused on the French agricultural productions. In France, we also have overseas territories. So we have the islands like West Indies, La Réunion. So we also work with these areas. And we have basically all the most common agricultural products that we can find in France. So we have all the field ingredients. We have the annual crops and grasslands. We cover fruits and vegetables and livestock. And in addition to all those data on the products, we have all the supporting LCAs that are required, the tractors, fertilizers, buildings, so on. That can be useful also for you in other contexts. This table is just for you to have it. If you want more detail, I won't stop on it right now, but you have all the list of Agribalyse products. So concerning the methodology we have implemented, the functional unit is 1 kilo of product, so it's always a mass functional unit that we have. The time period for the agricultural practices is 2005 to 2009. We stop at the farm gate. We don't have any processing data so far. For foreground data, we've been working mostly with statistical data to represent the agronomic systems, but also we had to use a case study and experts for when the statistical data was not available. For direct emission calculation, we always try to use models that are suitable for the French context. For background data, for all the agricultural products, we develop the own background data, so like for seeds, for animal feeds. And for the non-agricultural, we use EcoInvent 3.2, and we adapt it when it was possible. So for example, we made a French tractor from the Swiss tractor of EcoInvent. The representativeness of the product is the French average product we tried to make, and to get it we had to build it from like subsystems. So for example, the average French tomato is built from the cold greenhouse and a hot greenhouse tomato, and so based on the market average we can obtain the French average tomato. We also work on few organic systems, but on the whole, it's really like the main agricultural systems that are analyzed. We don't have so many like secondary systems in the database right now. Concerning system boundaries, I'm not sure how familiar you are with this, but on farms, there are most of the time livestock and crop at the same time, so it's important to know where we draw the line concerning the impacts. And so this is quite common approach for all databases. I lost you again.
We can hear you. I can hear you. Vincent? We'll just give him another second to try to rejoin. I'm not sure what's going on. Vincent? Let's see, I apologize everyone. I'm not sure what happened here.
I am back.
Okay, welcome back.
Well, sorry about these technical issues. I hope it will work now. Shall I continue or?
You can continue.
Yeah.
You're just talking about the boundaries.
Okay, so yeah. I was mentioning, so this is a common for like most databases, that we consider that all the activities related to livestock farming are put on the animals, so which means like all the animal emissions, but also the dejection management. And from the time the dejection are transported to get to the arable field for the crop as fertilizer, then it becomes an impact that is put on the crop, so from the transportation of the manure. For grazing animals, we have the same situation as we have LCA for the animal and LCA for the pasture. We need to split, even if at the end the cow eats the pasture. So when we go to the milk, we get all the impact together, but it's important for you to understand how the LCIs are built. So we consider that all the methane emissions are on the animal side, whereas all the nitrogen emission are on the plant production in the pasture. Here's a bit of a summary of all the flows that are considered in Agribalyse. Our aim really was to be as complete as possible, and we basically cover all the ILCD flows that are required, with the exception of carbon sequestration that is not considered in Agribalyse at the moment, because when the database was released, there was no agreement on how to account for this carbon sequestration. So we've decided to go on with the work and to include it in the next updates. We also work on the crop rotation to consider that some fertilization is not benefiting to the actual crop that receives it, but is meant to be for the following one in the rotation. So to consider these agronomic practices, we had a model to reelaborate organic fertilizers. For animal production, we also cover the main emissions. We don't consider leaching for the dejection because by law now the French farms have to make sure there is no leaching in their dejection manure facilities. So for the rest, it's a complete coverage of the flows. A slide about allocation. You know it's a sensitive topic for our food LCA. As we stop at the agricultural step, there is less allocation debate, as most of allocation occurs at the processing, in the processing steps. However, we do have some allocation to do. For example, for the cows and between the milk and the meat, and for this we worked with a biophysics allocation. Here is how it works. So we have the cow with splits between the growing phases. So we consider that all the younger years, when the cow is growing up, that this environmental impact are connected to the animal, to the cow. Also the latest time period when it's fattening. So all these environmental impacts go to the cow and finally to the meat. During the milking period, when the cow is producing both milk and calf, and here we need to have a sub-allocation, and we base it on the energy requirements to produce milk and to produce calf, which is given by a standard equation from the animal production that is currently used when they prepare the feed. For people familiar with this allocation, it's very similar, the approach to the IDF, so the International Dairy Federation approach, and also that there is the PEF approach, but the values are slightly different, so it's not exactly the same, but the overall is similar. When we are producing a database, one big challenge is the data quality and the quality control. Indeed, we're working with thousands of data and we need to have some procedures to ensure the highest quality possible. So that's how we've been working in Agribalyse, that we always try to have a cross-checking. So for the description of agricultural practices, this was done by the technical institutes, and it was reviewed by external experts. On the LCI and LCA indicators, also been a review. So the calculation was done by the research institutes, and the review was done by the technical institutes. So it was always this cross-validation, which has been really important as we realized we really identified a lot of improvements through this process. We've been going on with this quality control with the user feedbacks. So it's been now almost 3 years that the database is public, and we are collecting all the questions and feedbacks, which enable us to correct many small mistakes and to contribute to the improving of the quality of the database. One slide about the comparison of other agricultural databases, because I assume you're familiar with them, probably using some of them, and it's interesting to see the difference or similarities with Agribalyse. So I'm not going to go into the detail, but just focus on some key criteria that you should look at when combining, if you want to combine databases. So we saw that like each database developers have a bit different goals, which also explain some structure and methodological choices. The country focus is not the same, so we have some databases that are global, others that are more country specific. And the global idea is that we try to limit overlaps. There is so many systems and products to analyze that we try to not to repeat the work unnecessarily. And you find few French data in AgriFootprint, but it's quite limited, and same with World Food and so on. The scope can be a bit different from agricultural to whole food system. What is an important point you should look at is background data. In Agribalyse 1.3 we use now EcoInvent 3.2, whereas in AgriFootprint it's ELCD, and in World Foods they are switching currently from EcoInvent 2 to EcoInvent 3. I'm not sure how far they are right now, but this can have a very significant impact on the results. Regarding modeling approach, we also observe some differences. In Agribalyse, our aim is really to support the development of the best agronomic practices, environmental practices, and in order to see the benefit from these agronomic practices, we need to have detailed models that consider the soils, the farming practices, and on an accurate way. Whereas other databases that are more focused on the food sector, they stick to a more simple approach with less data demanding. So, and this can have also quite significant effect on the result. There are some differences regarding the allocation approach. For the availability, Agribalyse is one of the very few public and free database that is provided through SimaPro and Open LCA. And also we can discuss if you want to use other softwares. And yeah, the idea about this data is really that these databases, we know each other, we have a global common understanding on what is a good quality data and how we should work. However, when you look into the details, you see some differences that can really affect the results, and this you should pay attention if you combine the data. So facing this, where we try to work and to develop cooperation with the other databases. We've joined, for example, the World Food Database and Agri-Footprint to answer to the PEF call for tender. So PEF is building a database as part of the European eco-labeling scheme. And we've joined the data from Agri-Footprint, World Food Database, and Agribalyse. So like for each country, the best data would be available. So for France, we take the Agribalyse data. For the Netherlands, we take Agri-Footprint, and so on. We try to follow the international guidance also, so the ISO, the ILCD, the LEAP standards. It's important harmonization efforts, those platforms. However, sometimes it remains quite open to be able to adapt to different situations. So there's different options that are possible. And when you're building a database, you need to be practical and operational based on the data availability. So if you look at our methodology guideline, it will be more specific than this guidance. And finally, we try to participate to the scientific conferences and to also promote discussion for further database harmonization possibilities, see which parameters it's required and which for them we should keep some flexibility. So, as I mentioned, the Agribalyse 1.3 version is available now. So until the end of last year, it was Agribalyse 1.2. And here are the main changes. The first one is the background database. So we used to be with EcoInvent 2 and we switched to EcoInvent 3.2. So following this, we had to use the market process and adjust the transportation modeling. And also we had to adjust the mapping file because for many products there is a default counterpart from EcoInvent 2 to EcoInvent 3, but for a few of them we had to define that manually, which was the good LCA to use. We have new LCIs. We have integrated all the feeds from the EcoAnim project. So that's more than 200 feed LCIs that are available in Agribalyse, and that have been also used to feed our animals and to replace older INRA data that were a bit outdated. And also we implemented some minor corrections that we get through the support, and this is all described in the report of changes. We try to provide an overview of this change, and we saw quite interesting things like that really highlight the stability of the indicators of LCA and agriculture products. We saw that for climate change, the new version, the results are very stable with less than 10% changes most of the time. Whereas for some impact categories, as ozone depletion, resource mineral depletion, ecotoxicity, freshwater eutrophication, we have some strong changes. These changes are due to the switch from EcoInvent 2 to EcoInvent 3. We have analyzed this, and that was really clear. For land use, it's a bit different. We realize that in Agribalyse 1.2, the land use approach was not reliable due to the statistic data that were used and were not really representing the land use dynamic, and so we decided to set the land use to 0. I'm done with the content of the database itself, and before I go to the question, I thought it would be interesting to open to the broader Agribalyse program. So this is all ongoing work that is currently currently done, and that will be integrated into the database in the coming years. We have been working on including new LCIs for the products that are missing in the database. So we've been working, for example, on seafood products, on some more fruit and vegetables. We also try to enlarge and not to stick to the national average products now, but to highlight the eco-design system. So what is the environmental benefits if you implement the best agronomic and environmental practices in your agricultural system, and try to get LCI for this eco-design system. So we have this in the pineapple for La Réunion island with the champagne sector that is working, also project on organic production. And one important change to be expected is the inclusion and enlargement of the scope through the inclusion of Acivia data. So this is food processing. So our aim is really to move from an agricultural database to a food system database covering from the field to the fork. We also go on with indicators and improving the methodology, as we had clearly identified some shortcomings after the first phase of Agribalyse, and we work on soil carbon, water footprinting, and pesticide assessment. And finally, we have all the reproducibility maintenance aspects. So this update from Agribalyse to Agribalyse 1.3 was part of it. And we also have developed a tool with INRA to make the calculation easier and for people to be able to repeat Agribalyse LCA following the same methodology in a much easier way. So I'm giving here some more information about this software. It's a software developed by the Research Institute, INRA. And the aim is really to provide a framework where non-expert, non-LCA expert could type in and describe the agricultural system in a rather simple and straightforward way into the software to get LCA Agribalyse type. The big added value is also the direct emission modeling. So here you have all the default parameters, and when you describe your agronomic system, you have all the direct emission calculated through the models that were selected for Agribalyse. Once you've done the calculation, you get a file that you can export towards SimaPro, and then you can finalize your LCA and make the characterization. It's web access open since the beginning of the year. There is a license fee that depends on which kind of institution you are. Possible trainings also are available, and if you are interested, I really suggest you contact the MINS INRA team. One word about the use of our data. So the data is available for last 3 years, and we've observed that it's been used for many different kind of projects. So for the one we were expecting, like eco-design approach, eco-labeling, but not also only the official schemes, but also like catering and restaurant associations that want to provide sustainable meals for their clients. There's been some work about nutrition and diets, so at the diet level, to assess what is nutritional and environmental sustainability in the diets, and also studies on the policy and like the strategical development, what would be sustainable consumption in the 2030, what is the impact of the changes of the food system and the potential benefits. Also lots of work on bioenergy contributions. What is the challenge regarding all these uses is that each of these those users have different expectations and backgrounds, and some would like really basic, simple data, like for nutritionists, most of the time European milk would be quite enough. Whereas for eco-design, people really want to have detailed information on the agricultural system, and we need to find the right balance to satisfy all these people. For the coming years, our priority is really now to support life cycle thinking in the companies and for the stakeholders, because we've been investing a lot in this benchmark and this methodology, and now we believe that there are lots of tools available and that stakeholders can really use and try to get this life cycle thinking and environmental benefit quantification implemented. The wish is really that the data can be used at the same time to broadcast the best environmental practices that are already known, identified, but that need support to justify the investment, and at the same time to create new products and really work on more radical innovation. And so that can be the case with new food on plant proteins and these kind of things. I'm getting to my conclusion. Well, I hope the data can be useful for many of you. It's a public and really consensual databases that we are providing for French products, can be used for like similar conditions, I think, in other countries if you have no better data. It's also an ongoing work, so we are always pleased to discuss if you have some suggestions, some expectations. We're really on a quite open process for the development of the work, and I'm really looking forward to your questions. Here you have two links. One is to our web page where you find all the documentation, and the other one is on SimaPro platform to download the data in the software.
All right, thank you so much, Vincent, for that great presentation. If anyone has any questions, we haven't gotten any so far. If you want to submit them in the chat box, we would be happy to answer them. We'll give people a couple minutes to get their questions together, and if some come through, I'll read them out. Let's see. Could you talk about the differences in implementation between the SimaPro and Open LCA versions? Name the names of elementary flows.
Yeah, there's been a bit of work to make some mapping file on the formats. Here I'm not very the expert on this, but also the characterization is a bit different. So if you use ILCD characterization method on SimaPro and on OpenLCA, you will find some slight differences. So yeah, we've been observing interesting things based on the software you use.
Is land use not taken into account in the 1.3 version of the database?
Yeah, the land use change, exactly, and the carbon sequestration.
Okay, thank you. Let's see. Can you be more specific about the biophysical economic allocation? Can you give a bit more of an explanation?
Regarding, you mean the slides, I explained, I think it's, that was, you would like say something you did not understand from this slide?
Yeah, she just asked if you can give a bit more of an explanation about it. Or give
well, really the idea is really to divide the life of the animal in different periods, and some periods are for the milk and other are for the cow, and so we divide then the impacts based on this splitting of the life period of the animals.
Okay, yeah, and if you have more specific questions on that, you can also follow up with either one of us directly, and we'd be happy to answer your more specific questions. Just to clarify, did you say that means allows a direct emission model to be customized for different productive circumstances?
Yes, the means in out tool is provide a connection between the description of the farming system and the models. So, and based on your expertise, you can use either the default parameters, or you can use your own parameters in the models.
Okay, thank you. Let's see. Is only land use change not included, or is also land occupation not included?
Land occupation is included. It's only land use change.
Okay.
In France, there is no big land use change. There's a bit of urbanization, but it's not like Brazil or this kind of countries. And so we have these small variations which are not very well captured on the statistics. And we had the first approach developed, and we had some unrealistic results. So that's why we decided to set it to 0 rather than to give these fake impressions.
Okay, can you explain something more on the impact on soil organic matter of activities? What data do you use, for instance?
Well, we did not account for the soil organic carbon and sequestration, as there was no agreement on how to account for the storage and emission of especially in the pasture and crop conversion situation and long-time pastures. So there is this SOC project that we have in France. So it's been working for more than 1 year, and we really hope we can make case studies and we can get to an agreement between the partners to define how we account for this carbon sequestration in all the situations we are facing.
When you import the data in SimaPro, would it be a system or a unit process? Are you able to modify the data yourself? So I can answer this one. It is a unit process, so you're able to see all the inputs and outputs and modify whatever you need.
It's mostly unit process. For a few data sets, we have confidentiality issues, and we had to maintain a system process. So that's the case, for example, for tomatoes, where you only have the average tomato, you don't have the heated greenhouse tomato and non-heated one.
Next, this is our last question, so if anyone has any other questions, please submit them now, otherwise this will be the last one. You mentioned changes made to the EcoInvent Swiss tractor to create a French tractor for Agribalyse. What kind of changes were necessary? Is a tractor in Switzerland that different from one in France? And I apologize for the sirens going by.
No, it's a good question. Yeah, we observe that Swiss tractors are smaller than in France. It's because you have lots of mountainous agriculture, and so the average Swiss tractor is clearly different from the average French tractor. And that's the adaptation we made. We changed the size, basically, and the power of the engine.
Okay, great. Thank you. So that is all of the questions. There aren't any other ones, it looks like. So thank you, everyone, for joining. And if you have any other questions, oh, one more came in. Is there an impact assessment method more suitable with the database Agribalyse?
We try to connect with ILCD characterization methods, but the characterization methods are also evolving, updating, and it's really the user responsibility to check that it's all connected. But we try to be in line with ILCD.
Okay. All right, great. Thank you, everyone. And yeah, if you have any other questions, you can follow up with me or Vincent, and we'd be happy to answer any other of your questions. And thank you so much.
Thank you very much for attending and for all your questions, and yeah, I'll be always glad to answer if you want some more details or if you have questions regarding other national initiatives in your countries, and we can share our experience. We are open for discussion. Thanks a lot and have a nice evening.